Okay, in this tutorial, I'm going to help you answer an exam question that deals with this area of knowledge. This is the revision checklist for atmosphere. And I'm going to specifically help you answer a question that relates to using diagrams to explain why there is more heat in the tropical areas, or more solar energy, and less towards the poles. There is a model answer for it if you want to look in the model answers, and you can see it here as written down. Now, it is likely, or you may very well possibly get a diagram that looks a little bit like this, which shows you that there is a surplus heat around the equator and between the two tropics, and then there's a deficit of heat north and south of the tropics. If you want to get more information from your textbook about this, page 17, 18, and 18 of the textbook about energy receipt helps explain some of these concepts. Now, the first thing to understand is you might be actually asked to describe a graph like this. So what is it actually showing? Because it looks kind of complex at first. We've got to imagine that this is the equator. So there is the equator, it represents this on the equator of our planet. And what it shows us is that the equator gains an awful lot of solar radiation. It gains far more solar radiation than the North Pole, and there's the North Pole, and there's the South Pole. Okay, so in terms of its average annual amount of solar radiation it's getting a lot more than the two poles. But of course, it's not just what an area gains, it's also what it loses, and that's where the other line comes in. So the blue line represents how much is being lost, how much is being re-emitted from the planet. And we can see that the equator is losing more than the poles also. Now, you would expect that because it's gaining more, so it's going to have more to lose as well. To understand this, the gap between the gain, which is the red line, and the losing amount, which is the blue line, represents whether there is overall more or less. So the surplus, this whole area is in surplus, and the reason it's in surplus means basically it means it's getting more solar radiation than it's losing. These 2 points where the lines cross, these are the tropics, the Tropic of Cancer and the Tropic of Capricorn. They represent the point on the planet where the amount being gained is in balance, is equal to the amount being lost. When you go north of this point, or south of the Tropic of Capricorn in this point, well, then you are actually getting less than you are losing. So you are in deficit. So you've got less heat energy. And that broadly explains why the North Pole is so very cold and the equator is the hottest area, because it's the most in surplus. It gets far more than it loses, and the North Pole loses far more than it gains. Right, so that's a description of the graph. Now we need to explain why there's this massive surplus on the North Pole, on the equator, and why there's these huge deficits of heat energy on the two poles. Okay, the first point is all to do with the angle of incidence. And that's what you would write. And that is to do which the heat energy from the sun strikes the Earth's surface. Now, due to the curvature of the Earth, the fact the Earth is curved, heat that strikes the equator is striking it directly overhead, and therefore is only having to heat a relatively small area of land. Okay? Whereas heat energy, the same amount of heat energy traveling towards the North Pole, is hitting the planet's surface when it is curved away from the sun. Because of that curvature, the same amount of heat has to heat a much greater area of the Earth's surface. Now, if the same amount of heat is having to heat a greater area, that area will naturally be much cooler than this, where a lot less area is having to be heated. So that is the angle of incidence. Now, we just take this little idea a bit further with the small area and the larger area. We can see another key aspect about the curvature of the Earth. If we take one beam of solar radiation hitting our atmosphere, at the North Pole, because of the curvature of the Earth, it has to travel through a greater distance of atmosphere to get to the surface than it does at the equator. So that distance from there to there is less than from there to there. Now that's important because the longer it has to travel through atmosphere, the greater chance that solar radiation is going to be absorbed by a cloud floating in the sky, or is going to be reflected by rain droplets, or scattered, and either traveling around the atmosphere or back out to space. So the longer it's traveling through the atmosphere, the more chance it's going to be reflected or scattered or absorbed and never make it to the surface. Because that distance is quite small at the equator, there's a greater chance it's going to make it to the surface and heat. Okay, so that's your second idea. It's the distance of atmosphere through which the solar radiation has to travel, which influences its chances of getting scattered and absorbed or reflected or not. Now, the third idea is to do with how directly overhead the sun is. Because the sun is in the equator is directly overhead most of the year, it is very concentrated, a bit like a light being focused through a magnifying glass. And because it's very concentrated, it will heat that area to a much greater level of intensity than if it is coming in at an angle and is therefore spreading out and is less focused and therefore heats the area a lot less. Okay, another reason why the North Pole is much colder than the South Pole. It's all to do with the albedo effect. Now, because the North Pole is colder naturally anyway, for the reasons I've already explained, the first two reasons, there is a lot more snow and ice in this area because water doesn't fall as rain, it falls as snow, and that builds up into large ice sheets like we can see on Greenland, or that we actually see the top of the planet being the sea being frozen, the Arctic or Antarctica. Because of this, that creates a huge area of white surface at the top and bottom of our planet. Now, ice has a very high albedo. That means there's a high chance that solar radiation is reflected when it strikes this light white surface, a bit like a mirror. In contrast, the equator has huge amounts of dense, dark rainforest. If you think about trees having green foliage, these huge areas of dense, dark rainforest, rather than reflect, they absorb huge amounts of solar radiation. So they have what's called a very low albedo. And therefore, the solar radiation that does arrive at the equator is getting soaked in and held onto a lot more than the solar radiation arriving at the two poles because it's being reflected. So that's an additional reason why a lot more is lost at the pole and a lot more is retained at the equator. Okay, another reason and final reason is to do with the tilt of the Earth. Once again, also to do with the angle. We have the northern part of our planet, like Norway, for example, which will spend most of the day. So in the middle of winter in Norway, you will barely see sunrise. That's why you see the northern lights in wintertime. So the sun barely rises. In the middle of winter in northern Norway, it doesn't rise at all for an entire day. And they'll have total darkness for at least a month. What that means is that there is no solar radiation arriving at all in the northern parts of the planet during our winter, and the same happens in the southern parts of the planet during the southern hemisphere. That means those areas are in negative receipt. They receive nothing. They just lose everything they built up during the summer, and they're not actually receiving anything. If you go to the equator, in contrast, it receives solar radiation all year long. There is no point on the equator where you ever have less than at least 10 hours of daylight. The day and the night are roughly equal all year long because the sun is always directly overhead because the equator is always facing the sun. So they get approximately the same amount of solar radiation all year long, and therefore there's never a period of time they're not receiving any. And that is a final reason to explain why, if we go back to the original graph, why the equator first of all receives a lot more, but also why it's able to retain it because of the dark rainforests. In contrast, the poles are receiving very little, and they are losing. They're losing less, but that's also basically because they're receiving a lot less. Okay, so have a little think through the points I've explained, read through the model answer, and hopefully you'll be able to answer a question that looks a lot like this with the aid of an annotated diagram. If you are asked to do a diagram, by the way, one final point I should make out is that you do need to sketch a simple little diagram. You probably want to sketch a simple diagram sorry, that looks a little bit like this with the sun striking. Your diagram does not need to get any marks in of itself. You could write an entire answer as long as you have some simple diagram